A circuit is a physical path between two or more points where each end connects to a port, either an electrical or optical interface. There are three main types of circuits used in telecommunications. Two-wire circuits use two electrical conductors. These are the most common type found in the analog local loop, the connection between your phone and the first point of access into the network. Physical four-wire circuits use two pairs of electrical conductors, one pair for transmitting and one for receiving. These are used for connections between PSTN switches, for leased lines, and for digital circuits where full duplex communication is needed. Logical four-wire circuits physically have only two conductors, but they create separate transmit and receive paths by using two different frequencies. This is a clever way to achieve full duplex communication over a two-wire medium. Now let us define three fundamental terms that describe how connections are organized in a network. A channel defines a logical conversation path. It is the frequency band, time slot, or code over which a single traffic flow travels. The number of channels in a transmission line determines how many simultaneous conversations that line can carry. A line is a connection configured to support calls generated by one user. Think of the phone line coming into your house. It serves you, the individual subscriber. A trunk is a circuit configured to carry calls from a group of users. Trunks connect two switches in the network, while a line serves one user. A trunk is a shared highway between switches that handles traffic from many users simultaneously. Virtual circuits are a series of logical connections between sending and receiving devices in a packet switching network. Unlike a physical circuit that reserves a dedicated path, a virtual circuit uses table entries inside each switch to route data along a predefined path. The connection is established after the sending and receiving devices agree on communication parameters, including message size, the path to take, error acknowledgements, flow control, and error control procedures. There are two types of virtual circuits. A permanent virtual circuit, or PVC, is available on a permanent basis. It is manually configured by the network management system and remains active at all times, similar to a leased line. A switched virtual circuit, or SVC, is set up on demand. It is provisioned dynamically using signaling protocols, must be re-established each time data needs to be sent, and disappears after the data transfer is complete. This is similar to a dial-up connection in the PSTN. Finally, let us look at the three main types of network connections. Switched network connections work like a traditional dial-up call. The connection is established through a series of network switches, and it exists only for the duration of the communication. Each time you connect, the path through the network may be different. Leased line network connections provide a permanent link between two fixed points. The transmission always follows the same path and the connection is always available. Organizations use leased lines when they need constant, reliable connectivity between locations. Dedicated network connections are a special case of leased lines where the end user actually owns the transmission equipment. This makes the connection exclusive to that user, providing maximum control and security. Let us review. A circuit is a physical path that comes in three forms: two-wire for the local loop, physical four-wire with separate conductor pairs, and logical four-wire using frequency separation. Channels, lines, and trunks organize network connections. Channels carry individual conversations, lines serve single users, and trunks connect switches. Virtual circuits provide logical paths in packet networks as either permanent PVCs or on-demand SVCs. And network connections can be switched, leased, or dedicated, each offering different trade-offs between flexibility and reliability. In the next lesson, we will explore the electromagnetic spectrum and how bandwidth is defined.